In this section, we're going to take a look at the basics of equation solving. For our purposes, equations fall into two categories. They're either linear or they're nonlinear. Linear equations are easy to solve. You've solved many linear equations in your life. The whole key to solving a linear equation is recognizing that the equation is linear. So a linear equation might look something like this. 2 times x plus 7 equals 5x minus 9. And what you need to do is you need to recognize that's linear. In math, linear doesn't necessarily mean the graph is a line. What it really means is you just have an x. You don't have any powers on the x's. You don't have any square roots on the x's. You don't have any fractions with x on the bottom. You don't have any other functions like sine or cosine. It's just an x, and that's what we have here. So, like I say, I'm sure you've solved many linear equations in your life. This one, you would get 2x plus 14 equals 5x minus 9. You would get all the x's on one side, so you might subtract 5x on both sides. And you would get all the numbers on the other side. So subtract 14 on both sides. And when you do that, you would have minus 3x equals minus 23. Finally, divide both sides by negative 3. And you end up with x equals 23 over 3. So there's a very simple linear equation, the type you should definitely be able to solve. I'm sure you've solved many of those in your life. Now, I do want to talk about a kind of linear equation that tends to bother some students. Hopefully this won't bother you. The ones that bother some students are ones that have fractions in them. So here's one that I just made up. 1/2 x plus 1/3 x equals 1/4 x minus 2. Now, a lot of students try to solve these dealing with the fractions, which will work just fine. What I like to do is I like to make them easier. And what I mean by that is I look at all of my fractions and I find a common denominator. For 4, 3, and 2, the common denominator is 12. So what I'm going to do is I'm going to multiply everything by 12. And the reason I multiply by 12 is 12 and 2 I can reduce. That becomes a 6, so I get 6x. Minus 12 and 3 reduces to be a 4. There's 4x. Equals 12 and 4 reduces to be a 3x. Minus 24, and that's an easy one to forget right there. Sometimes students will forget to multiply that one by 12. Notice what we have now. Now we have an equation with no fractions in it. So, that's a general rule that we're going to have in this class, something we're going to do. Anytime we have an equation and the equation has fractions, we're going to get rid of the fractions. Alright, now we combine our like terms. 2x equals 3x minus 24. 24 didn't come out very nice, did it? 24, there we go. Subtract 3x on both sides. Minus x is minus 24. Divide both sides by negative 1. X is 24. Alright, so that's linear equations. Now, in reality, most of this course is going to deal with solving nonlinear equations. We're going to learn how to solve all sorts of nonlinear equations. We're going to do quadratic. We're going to do a little bit of those today. And then we'll do equations that have power 3, power 4. We'll talk about exponential equations, logarithmic equations, trigonometric equations, rational equations, radical equations, all sorts of equations, all of them nonlinear. Alright, so nonlinear. The key to nonlinear equations is factoring. And that's why we studied factoring in the previous section. So let me give you a nonlinear equation here. How about y squared minus 4y equals 45. Alright, first thing is we recognize that's nonlinear. It's nonlinear because it has a y squared. To solve a nonlinear equation, traditionally what you want to do is get everything on one side and 0 on the other. So I got everything on one side, 0 on the other. I subtracted the 45. Then we factor. That's why we studied factoring in the previous section. Let's see, we're going to have a y and a y. And this one looks like it's going to be minus 9 plus 5. I think that'll work. Now, the reason we factor and the reason we want 0 on one side is we want to use something called the zero multiplication property. So notice what we have. We have two things multiplied together. We have a y minus 9 and a y plus 5, and we're getting an answer of 0. The only way that can happen, the only way you can multiply two things together, is the first one has to be 0. You have 0 times something, or the second one has to be 0. That's the only possible way you can multiply two things together and get an answer of 0. One of them has to be 0, or the other one has to be 0. So notice what we've done. We've taken our nonlinear equation, factored it, and we've turned it into two linear equations. We solve each of the linear equations, y equals 9, or y equals negative 5. So, notice we end up with two answers. We started with a y squared. We had two answers. When we started with our equations that just had x's, no x squareds or anything, we only got one answer. Alright, let's try another one of these. How about 24 equals x times x minus 2? Alright, well on the surface this one doesn't look nonlinear because I just see x and an x, but of course when we make a move to simplify, when we distribute that x through, we do see that this is a nonlinear equation. It has an x squared in it. Alright, so I'm going to move the 24 over to get my 0 on one side. And now I see I have my equation. Now this is kind of equation, this is called quadratic. It's called quadratic anytime your biggest power is a 2. So we have an x squared. These are known as quadratic equations. I'm guessing you've probably studied quadratic equations before. Once again, we factor. This one looks like it's x minus 6, x plus 4. We use our zero multiplication property. X minus 6 has to be 0, or x plus 4 has to be 0. Solve each one. X is 6, or x is negative 4. Okay, so you're going to solve some quadratic equations in this section. The quadratic equations will be along this line. They're ones that you will be able to factor. In the not too distant future, we will study how to solve quadratic equations that don't factor. And again, my guess is you've probably seen that before. The last thing we have in this section are what are known as literal equations, also known as formulas. And if you're taking a science class, physics, or chemistry, you deal a lot with literal equations. So a literal equation might look like this. 2w plus 2h equals p. So that's a literal equation. A literal equation is just a formula. It's an equation that has more than one variable in it. And you might be told, solve for w. Right now we would say this equation is solved for p. What I mean by solved for p is on one side I have p all by itself, and there's no other p's anywhere in the equation. Quite often in science, chemistry, biology, physics, once again, when you have a formula, you need it solved for another letter for various reasons. So in this case, we want to get the letter w all by itself. So to get the w all by itself, we would subtract 2h on both sides. And we would have 2w is p minus 2h. It's just like solving any other linear equation. This one's linear. There's no powers or anything. The difference is we can't combine our like terms. There's a p and an h. We can't combine them. That's okay. Divide by 2. Making sure you divide everything by 2 over there. Your answer would be w is p minus 2h over 2. And a real common mistake I would see students make is they'll cancel those 2's there. You can't do that. If you're going to cancel a 2, you need to be able to cancel it everywhere. We'll talk more about rational equations like that in the future. Alright, last problem. Let's say you have Q equals P minus NP. And this time we want to solve for P. Alright, once again, this equation is solved for Q. What we want to do is solve for P. Now this one's a little different. And what's different about this one compared to the previous one, P shows up more than once. So what you need to do when P shows up more than once is you need to factor. So on the left-hand side, I have the Q. And on the right-hand side, I have P, and I have a common term of P. So I'm going to factor the P out. Left over, 1 minus n. And then finally I get the P all by itself. I divide by the 1 minus n, doing that on both sides. So my final answer is Q over 1 minus n equals P.